Hello everyone, my name is Pallavi Jaiswal. Today I am going to explain the topic curl, divergence and gradient in tensors. Starting with the curl of a vector. Let AI be a covariant vector. Then we have ai, j is equals to del ai upon del xj minus ap in the bracket pij. Consider it equation 1. Interchanging suffix I and j and noting that pij can be written as pji. We get aj, I is equals to del aj upon del xi minus ap in the bracket pij. Consider it equation 2. Now subtracting equation 2 from 1, we get ai, j minus aj, I is equals to del ai upon del xj minus del aj upon del xi. The tensor ai, j minus aj, I of rank 2 is defined as the curl of a vector ai and is denoted by the curl ai. Thus, curl ai is equals to ai, j minus aj, I. Now our next topic is gradient of a scalar. Let phi be a scalar or invariant. Its covariant xi derivative is denoted by phi, I and is defined as the ordinary partial derivative of phi with regards to xi. So phi, I is equals to del phi upon del xi. Clearly phi, I is equals to del phi upon del xi, which is equals to grad phi and can be written as nabla phi. Now we will understand divergence of a vector. Let ai be a contravariant vector. The divergence of ai is defined as the contraction of ai, I, or in other words, the contraction of covariant derivative of ai is defined as the divergence of vector ai. The divergence of ai is denoted by divergence a to the power I. Thus, divergence of ai is equals to ai, I. Now understanding the theorem of divergence. If ai is a contravariant vector, then we have to prove that divergence of ai is equals to 1 upon under root g del upon del xi in the bracket ai under root g, where g is equals to mod of ij. So starting the proof. By definition of the xj covariant derivative of ai, it is given by ai, j is equals to del ai upon del xj plus ap in the bracket ipj. Setting j is equals to I, we have ai, I is equals to del a to the power I upon del xi plus ap in the bracket I pi. Now ai, I is equals to del ai upon del xi plus ap del upon del xp log under root g. As we know that bracket of I pi is equals to del upon del xp log root g. So substituting in the above, we get del ai upon del xi plus ap in the bracket 1 upon under root g del root g upon del xp. This can be written as del ai upon del xi plus ai under root g into del root g upon del xi. By replacing dummy suffix p by I, we get 1 by root g in the bracket del ai upon del xi under root g plus ai del root g upon del xi, which is equals to 1 upon under root g del upon del xi in the bracket ai under root g. So divergence of ai is equals to ai comma I, which is equals to 1 upon under root g del upon del xi in the bracket ai root g, for which I is equals to 1 2 till n. Now getting on to the next theorem. We have to prove that divergence of ai is equals to divergence of a to the power I, where ai and a to the power I are the covariant and contravariant components of the same vector A. Coming to the proof, we know that the divergence of a covariant vector A subscript I is defined by divergence of A subscript I is equals to G J K A J comma K. Divergence of AI is equals to G J K A J comma K. Since G J K is constant, divergence of A subscript I is equals to A K comma K, which is equals to a subscript superscript of I comma I. By replacing dummy suffix by I, we can see that divergence of a subscript I is equals to divergence of a superscript I. Now coming to the next theorem, we have to show that grad of phi psi is equals to phi grad psi plus psi grad phi. Coming to the proof, by definition of gradient, we know that gradient of phi psi is equals to nabla of psi phi, which is equals to del upon del x superscript I in the bracket phi psi, which is equals to phi del psi upon del xi plus psi del phi upon del xi. Since del phi upon del xi can be written as grad phi and del psi upon del xi can be written as grad phi, substituting in the equation we get phi grad psi plus psi grad phi. So we can say that grad of phi psi is equals to phi grad psi plus psi grad phi. Now coming to the last theorem, divergence of phi A is equals to grad phi into A plus phi divergence of A. Coming to the proof, we have divergence of A superscript I is equals to 1 upon under root G del upon del xi in the bracket under root G AI. Consider it equation 1. So divergence of phi AI is equals to 1 upon under root G del upon del xi in the bracket under root G phi subscript AI, which is equals to 1 upon under root G whole bracket del upon del xi under root G AI phi plus under root G AI del phi upon del xi. This can be written as grad phi into AI plus phi divergence of AI. Now we can say that divergence of phi A is equals to grad phi into A plus phi divergence A. Thank you for listening my presentation.